Hey, math fans, welcome to section 1.2.2 in Math 1. Let's get started. Take a moment to pause the screen and take a look at the different symbols versus their description, an example in the solution set for each of these, the greater than or equal to, less than or equal to. Take a moment to pause it and we'll talk about it. Each one of these symbols means something different, and you really should pay attention to the direction. And also, especially right here, this is different than this because it does not include the actual number in this particular one, but it could be equal to the number here. Does not equal. Take a moment, pause that, and we'll move on to the next slide. Example 1. Juan has no more than $50 to spend at the mall. He wants to buy a pair of jeans and some juice. If the sales tax on the jeans is 4% and the juice with tax costs $2, what is the maximum price of jeans one can afford? Okay, so this particular problem, we're gonna, again, create an equation, and I like to do the big picture stuff first. So let's do that. So here's a big picture way of doing that. You got stuff and you got money. Juan wants to buy some stuff. He's only got so much money. So my question is, how does the less than or greater than symbol fit in here? Where do you think it goes? Do you think the stuff should be greater than the money, or the money should be greater than the stuff? Okay, so the way I have this written right here is that basically he'll run out of money if the stuff costs more than the amount of money that you have. So let's erase that. This is the way we should be thinking of it. We should always have more money than however much the stuff costs, okay? So let's continue with this problem. I have no idea how much the pair of jeans cost because that's basically what this problem is all about. So we're just gonna write X. It's only one pair of jeans that he's gonna buy. And also we have to tack on 4%, which is 0.04% of the jeans. And that will be the total price of the jeans plus the tax. Oh, and let's not forget about the $2 juice that we have to include. Now, all of that stuff cannot cost more than the $50 that he has to spend. So here again, this has to remain less than the $50. So let's write the $50 in there. And there is your inequality. And so we'll subtract 2 from both sides. We'll combine the like terms on the left. And on the calculator, when I divide, because right here we're dividing, we're going to have to divide both sides by 1.04. We're dividing this by 1.04. I punch 48 divided by 1.04 into my calculator, and I get 4, 6, 1, 5, 3, 8, and there's a lot of numbers that go there, but we don't have to write all of them down because honestly, this is the price of the jeans. And remember, we can only deal with dollars and cents. We're not going to deal with fractions of a cent. So with money, we usually round up, but honestly, in this case, if we round up, it's not going to work out. We can't go. X has to be below this number, so we're going to actually round down because of this less than symbol. So the jeans better not cost any more than $46.15. Okay, there's your final answer there. Alexis is saving to buy a laptop that costs $1,100. So far, she's saved $400. She makes $12 an hour babysitting. What is the least number of hours she needs to work in order to reach her goal? Let's start with the big picture stuff. If However much she is saving is less than the computer. Can she buy it? No, she can't buy it. It needs to be greater than or equal to the amount of the computer. So this is actually incorrect. Let's erase that. It's actually, we need to have money that's we're saving needs to be greater than or equal to the computer. So there's your big picture statement. Sometimes it's helpful just to start with the big picture first. So far, she has saved $400. She's going to be adding to that amount every time she saves more money. She makes $12 an hour, but we don't know how many hours she needs to babysit. So maybe I'll put an H there. That'll be our variable for the number of hours. And then remember, this amount has to be greater than or equal to the laptop that costs $1,100. Now we continue to solve the equation. We subtract 400 from both sides. 12h greater than or equal to 700. We divide both sides by 12. 700 divided by 12 is 58.33333333, and it just kind of continues on that way. Again, what are we looking for? Well, h is the number of hours, so I don't know what 0.333333 of an hour is, and if you babysit, you're either going to get paid for 58 hours or you'll get paid for 59 hours. And since it has to be greater than 58.33333, let's go ahead and here's our final answer. H has to be at least 59 hours. That's terrible. H has to be at least 59 hours. A radio station is giving away 40 concert tickets. The station gives away 2 tickets every hour on the hour for a number of hours until there are at most 4 tickets left for a grand prize. If the contest runs from 11 a.m. to 1 p.m. each day, for how many days will the contest last? Let's do the big picture statement. So the problem states until there are at most 4 tickets left. So we need to make sure that the tickets given away are less than or equal to the tickets left. So here are the 40 tickets to be given away. We're giving away 2 of them every hour, less than or equal to 4. Negative 2h, less than or equal to negative 36. Now, be very careful here. There's a special rule when we divide by a negative number and we are working with an inequality like we are here, something strange happens. Does anyone know what that is? That's right. It's going to switch directions on us. And our final answer is h is greater than or equal to 18. 18 tickets. Sorry, 18 hours. H greater than or equal to 18. So the number of days. So H is greater than or equal to 18 hours. So it's going to take 18 hours to do this, but that's not what the question asked for. The question asked for how many days is that? So let's keep going. How many days are in 18 hours? Well, how many hours are in a day? That's right, 24. But in this problem, how many hours are we giving away tickets, though? And you kind of have to think about this a little weirdly. Let's see. If it's 11 a.m., because most people will think, well, it's only going to happen twice, but it's actually going to happen 3 times. 11, 12, and then 1. There's actually going to be 3 different giveaways. So what we're going to do is take that 18 hours and divide it by 3 times, because there's those 3 different times during the day, for a grand total of 6 days. And that's going to do it for section 1.2.2. We'll see you in class.